So today our objectives are to be able to use sample data to check the normal and large sample conditions, and then also use the four-step process to construct and interpret a confidence interval for a population mean. Remember yesterday we learned all of the formulas for calculating a confidence interval for a mean. And today we're going to use the same four-step process that we talked about in lesson 7.4. So a lot of today's activities should look pretty familiar, and once we have the data, you should be able to kind of follow your directions all on your own and come up with your solutions, and then we can check those together. So what kind of data are we looking at? Today we want to collect the following. How many states can you name in 1 minute? We're going to use this class as a random sample of high school seniors to estimate a 95% confidence interval for the mean number of states a senior can name in 1 minute. So typically what I would have you do is we would give you a piece of paper. We would start the timer at 1 minute, and you would list as many states as you can on that piece of paper. When the time is up, we would count how many states you named, and you would put that number up on the board. Since we're not able to do that together, what we're going to do is pull on some previous data that I've collected. And so running this with a previous class, these were the results for the number of states the students were able to collect. So using this data, it's also posted on Google Classroom. What we want to do is enter it into your applet under the one quantitative variable icon. So it's the same applet that we've been using before. Just make sure you're following your directions, going to one quantitative variable. You're going to enter the data in. You probably can copy and paste it from Google Classroom and find the following items. We're being asked to find N, which is the number of pieces of data in your set. X hat, remember that's the mean of your sample. And then we have our standard deviation of the sample. So all of that will be calculated for you in the applet, and it should generate for you a dot plot with the results for the number of states listed in 60 seconds. So what you could do is pause the video here, enter all that into the applet, get your summary and your dot plot, and put all of that on number 2 on your paper. When you're ready, you can continue on with step 3, following your 4-step plan, and then resume the video to check and make sure, have you gone through the process correctly and did you do your calculations correctly? Remember, you're going to want to use your table B for this, because as we saw in your lesson 7.4, we have to find your critical T value, and we have to use our table B for that. All right, by entering your data, we should have had the following results. The number of pieces that we had was 31. We then had our mean being 16.323, and the standard deviation was 4.861. And there was our dot plot based on our results collected for the class. So all of that should be present for your number 2. Remember, whenever you're making your graphical representations, you should have a title included to say what is it representing. Then as we continue on now with your 4-step plan, we're constructing a 95% confidence interval to estimate the mean number of states a senior can name in 60 seconds. So as always, we're in the state phase. We're going to state the parameter we want to estimate and the confidence level. So the parameter, what we're looking for, is the true mean number of states a student can name in 60 seconds. The confidence interval, or sorry, the confidence level we're looking at is 95%. So now we get into the plan phase, right? We're going to plan the appropriate inference method and check the conditions to see if they're met. If they're met, then we can perform the calculations. If not, then we cannot proceed. So we're talking about the plan phase. Again, name the procedure. Well, for us, we're getting one sample t interval for your true mean. The conditions that we have to check: is it random? Was it normal? And so, is it random? Yes, we randomly collected the number of states from the students. And then, is it normal? Well, there's a couple ways that we can look at this. One, we want to see what our count is, right? We know if the number on our sample is more than 30, it should be normalized, and we can continue on. If it was less than 30 and we didn't know the shape, we could not proceed, right? If it was less than 30, but we do look at the shape, looking at the dot plot, as long as the dot plot does not show any strong skewness or outliers, we can assume that it would be normalized if we added more samples to our data. And so for us, we had 31 pieces of data, so we're okay. We're saying that the sample is for your CLT theorem. But also, if we look at the dot plot, there was no strong skew to it. It also did not have any outliers, so we can proceed with our calculations. So what are the calculations that we're looking for? Remember, your general formula for any confidence interval goes back to the idea that we want our point estimate, and then we go to the right and left, because we're establishing our lower bound and upper bound, our margin of error. So in words, that's the idea that we're looking for. Now for us, we're looking at the mean of our sample, right and left, your critical t-value, times the standard deviation divided by the square root of the number of data. And remember, to get the critical t-value, we're going to use the table B, and we have to find the degree of freedom. So remember, degree of freedom is n-1. Once we establish that and we know the confidence level we're working with, we find where they meet in the table, and that's the critical t-value that will go here. You've already calculated the mean, we already calculated the standard deviation, we already know how many items are in the sample. So once we have that critical t, we're just substituting, following order of operations, and we'll have the interval. So if you were looking at going to the next step, we already have the mean, like I said, the standard deviation, and the number of data pieces. The degree of freedom is what we have to work on. Well, there were 31 pieces of data in our sample, so 31 minus 1 is 30. So when I go to table B, I look for the sample size of 30. I'm going to look for that confidence level of 95% and find my critical t-value, which is 2.042. That was the only piece that was missing, so I can substitute those 4 values into my pattern and follow the order of operation. So again, you're not using your cell phone calculators. You're going to use your Desmo scientific calculator or an actual scientific calculator, graphing calculator, to do this. And so if you remember your order of operations, to start, you're going to go through grouping symbols. You're going to take 4.861, divide it by the square root of 31, hit enter. Take that answer times 2.042, hit enter. That should come out to be approximately 1.783. We're going to use that for our margin of error, right? Or the standard of error. And so if I take 16.323 minus that, that gives me my lower bound. 16.323 plus that gives me my upper bound. And so my interval would be 14.54 to 18.106. So the last part of your 4-step plan is the conclusion. Remember, that's where we're going to interpret your interval in the context of the problem. And your conclusions, when we're talking about interpreting the intervals, always has the same sentence stem, where it looks something like this. We are C% confident that the interval from the lower bound to the upper bound captures the true mean of, and then we go back to the context of the problem. So for our problem, remember the context, we're talking about the true mean number of states a senior in high school can list in 60 seconds. So at this point, all we have to fill in is the confidence level, which we know is 95%, and the lower bound and upper bound numbers of the interval. So our final interpretation should be, we are 95% confident that the interval from 14.54 to 18.106 captures a true mean number of states a senior in high school can list in 60 seconds. So to recap, big ideas, right? For a confidence interval for a mean. One, we want to always check the normal and large sample conditions are true. If they are, then we can proceed with that four-step process. Remember, what we're looking for is the population normal. Is the CLT true, where n is greater than or equal to 30? If not, look at the graph of your sample data. Look to see that it does not have any strong skewedness or outliers. And if not, then you can assume that if you added more samples to your data set, it would have normalized. Now, your four steps, again, just like we did in your 7.4, you're always stating the parameter you want to estimate and the confidence level. Then you plan, so you're identifying the appropriate inference method and check your conditions. You're going to do the calculations as long as the conditions are met. And last but not least, you always do the conclusion. You're interpreting your interval in the context of the problem, going back to the sentence stem that we've always used, just substituting in the confidence percentage, the lower bound and upper bound of the interval, saying how it's capturing the true mean, and then always in the context of your problem. So at this point, you're going to continue using these ideas in your application for 7.6, talking about how tense are the video screens. And as long as you read through, mark the important givens in the problem, you should be okay going through your four-step process, just like we did here in our lesson for 7.6, which was similar to what we did in our lesson for 7.4. To come up with your results. And our next time together, we'll take a look at these last few lessons, looking at their similarities, finishing up our formula page, big ideas for the unit, to prepare for the upcoming assessment, which will also be using these ideas in your final exam project.